Hi, I finally just figured out why my volume is not working. I have the wrong had the wrong speaker or the wrong microphone or something. So now I'm redoing this for the third or fourth time. I'm not sure. So I hope I don't rush because sometimes when I redo something, I'm just like, get through it. So I'm going back to chapter 4.1 on random variables. This was a nice section. It should have been a nice section. The main purpose of 4.1, that was my dog, is that we are switching from thinking about a sample space to looking at that sample space and defining some numeric quantity on that sample space. So we want to make it like a sample space quantifiable in some way now. And we're going to do that by assigning a variable, which we could make a variable anything on that sample space. And then eventually we'll put probabilities with that random variable. So, of course, I forgot to review this. So there we go. So I just started off giving you a bunch of different kinds of random variables. Later we'll distinguish between the types, but right now just think of an object or a situation where you could get many different outcomes, and that's what a random variable is. I don't know what it's going to be, but there's many options. Right now I'm hooked on milk duds at school. That's always in our math office. If I open a snack box of milk duds, how many milk duds are inside? There could be 0, 1, 2, 3. So the number of milk duds is my variable, and it's random. It could be, 0, 1, 2, 3, 4. I don't usually get more than 5. I think you'd be really lucky in a snack box to get more than 5. Um, Number of libertarian voters when it comes to election time in November. Let's see what else. Yeah, the class we're in now that we have probability in currently, there's a window. So the amount of time we're in class before a squirrel comes to the window, one usually comes and watches for a while. The grade you're going to get on your first exam, that's a random variable, anywhere between 0 and 100. We hope the upper end. So these are all random variables, and here's a picture of the situation. Flip a coin twice. Here's your sample space you remember from earlier, and here are the outcomes that could happen when you flip a coin twice. X is some quantity you want to put on that sample space, so I'm calling it the number of heads. And so I'm going to map that sample space then to the real number line. This is a mistake. It should go through all real numbers, but I just have 0 and 1. That's a mistake. But when I count the number of heads on 2 tosses, it could be 0, 1, or 2. I don't have the 2 out here. So notice down here, now instead of writing the probability the sample space occurs, I just write the probability x is 0, x is 1, x are 2, because this is the only values that random variable can take on that have positive non-zero probability. And we call those the values that x can take on its support of a random variable. So almost every time I ask you for a random variable, I will ask you for its support. Otherwise, we don't know who it's defined for. Here was just a nice example. Toss 2 different dice. One is green, one is red. Add up their faces. So a 4 and a 2 would give you a sum of 6. A 5 and a 2, here's a 7. A 6 and a 3, here's a 9. These are all possible outcomes, 36 of them. So what is the support of this random variable? The sum of 2 dice could be anywhere from 2 to 12. And then we'll start practicing putting probabilities with those. And right now, a lot of it will just be counting. I mean, here's all the 36 possibilities. The probability x is 2, 1 out of 36. 3, 2 out of 36. I'm just going back to the table and counting. And sometimes it's nice, you can see up here, to put a nicer, what do I mean by nicer? Maybe a more succinct formula for x instead of writing out all the possibilities, but either is legal in this class. Sometimes impossible maybe to write out for everybody. Here's again, draw checkers from a box. How many of them are red? Count how many people in a society you have to test until you find a certain disease. All random, right? And random variables could be no people have it, 1, 2, 3, you have to test. The last little part in here that is kind of nice is that If you have a random variable, you can also make a function of a random variable. So if I tell you something about x, x could still be the sum of two dice. We could look at the random variable x squared, which is just the square of the sum of two dice. And it still has probability values associated with it. Or, I mean, I could take the cosine of the number on a die, or you can do anything with random variables. You can, apply any function to them. So sometimes we like to ask questions about functions of random variables. For example, if I know the length of a side of a square, for example, I might ask something about its volume. So probably x cubed is bigger than 28.4. Just put the statement in terms of x again. So if you have a statement in x cubed, square root of x, cosine of x, just change it over to be a statement. Just use algebra to change it over to be about a statement about x, and then calculate probabilities. For example, on 0 to 2 pi, what's the probability that sine x is bigger than cosine x? This only happens, I don't know if you remember your pictures of sine and cosine, this will only happen when x gets bigger than pi over 4. Remember, they're equal at pi over 4, so half the time sine x is bigger than cosine x on that interval. Here's another statement. X is a random variable in this interval. What's the probability this quadratic's bigger than 0? Well, I have to figure out what values of that quadratic make it positive. And again, I'm switching to a statement about x's. So sorry if I rush this too much and you want a slower version, but it's just, I think because I'm redoing it for I don't know what time, the nth time. But yeah, 4.1 pretty nice. 4.2, we do a little strangeness in going with the CDF, so I'll make a video on that right now and start posting again.